Find the mass capital M of the hanging block in the figure shown below, which will prevent the smaller block from slipping over the triangular block. All the surfaces are frictionless and the strings and the pulley are light. Okay, so for this problem, the first thing that we are looking for is we will understand the situation in this way, that this is one complete system which will be accelerating with an acceleration a towards right, and since it is connected by a single rope to the capital M mass, so it is also accelerating a in the downward direction. So this is the first constraint relation which we establish over here. Now we wish to draw the FBD in this way, that a force capital Mg is acting in the downward direction, and there is a tensional force which will be generated in the spring, and this tensional force will guide the mass M dash in M towards right. So these are the equations which we have framed over here. So now the question is asking us to calculate the mass of capital M of the hanging block, which will prevent the smaller block from slipping over the triangular block. So the first thing that we will solve is we will be solving for the value of acceleration for the system, and if we frame the equation, we can frame it this way. For the wedge M dash and the block M, we can write it as M plus M dash multiplied by A. This is the first equation which we have, and the second equation will be a force Mg in the downward direction, which is balanced by the tensional force, is equal to capital Ma. So if we put the value of T over here in the second equation, so we can deduce this equation in this form: minus of small m plus m dash A is equal to capital Ma. So this is the modified equation which we have. Suppose I call this as equation number 3. Now I am drawing the FBD for the mass small m and the wedge m dash. So this is the wedge m dash, and this is the mass small m which we have, which is kept inclined at an angle theta on the wedge m dash. So if we do the force analysis over here, I can say that the weight is acting in this downward direction, which is equal to mg. Now there is a component of weight which will be acting in this direction. This will be mg sine theta, and a force which will be acting perpendicular to the inclined plane, that is mg cos theta. Now since this system was accelerating with an acceleration a, I am applying a pseudo force on m in this direction, which will be equal to ma. So this is the pseudo force which we have applied, Fp. The pseudo force will act opposite to the direction of acceleration, and if I break the component of pseudo force, then we will get this component as ma cos theta and the other component as ma sin theta. So the component perpendicular to the incline will be balanced by the normal reaction force, but along the incline, for the block to be in equilibrium, it is important that mg sin theta, which is acting in the downward direction, is balanced by ma cos theta. So this is the requirement which we have, and from here I can write that acceleration a is equal to g sin by cos, that is tan theta. So this is the necessary equation which we have. This is the fourth equation which we have framed. So if I put the value of acceleration in the third equation, so from here we are looking for the value of capital M. So if we substitute the value in the third equation, putting it in third equation, we get it as capital Mg minus small m plus m dash into A, where A can be written as g tan theta, is equal to capital M. A can be written as g tan theta. So we obtain an equation like this. From here we can knock out g, and then we are looking for the calculation of capital M. So we can write it as capital M taken common, 1 minus tan theta is equal to small m plus m dash tan theta. So from here I can write that capital M is equal to small m plus m dash tan theta upon 1 minus tan theta. So we obtain an equation like this: the small m plus m dash tan theta upon 1 minus tan theta. Now we can do different sort of calculation to reduce this equation into other forms as well. We can convert it in terms of chord relation also, but that is not necessary for the time being. We are putting it in this way, that capital M is equal to m plus m dash tan theta upon 1 minus tan theta. Although if you want, you can convert it in terms of cot theta or any other trigonometric function for that matter.